Hello everyone, today we are going through rational and irrational numbers. We have already studied about rational and irrational numbers in 9th standard. Okay, today let's just revisit the rational and irrational numbers. We know that what is a rational number? A number that can be expressed as p by q, where p and q are integers and q not equal to 0, is called a rational number. That is, a number that can be expressed as p divided by q. Okay, here p and q are integers. P and q are integers and q not equal to 0 is called rational number. Okay, for example, 2 divided by 3 or minus 3 by 7 or 5, because we can write 5 as 5 divided by 1, right? 5 and 1 are integers. Okay, so 5 minus 8 divided by 6, etc. Okay, next, irrational number. What is an irrational number? A number that cannot be expressed as p by q, where p and q are integers and q not equal to 0, is called an irrational number. Okay, that is, a number that cannot be expressed as p by q, where p and q are integers and q not equal to 0, is called irrational number. For example, root 2, root 3, root 5, pi, etc. Okay, these numbers cannot be expressed in the form of p by q. Now let's go through a theorem, very important theorem. Let p be a prime number and a be a positive integer. If p divides a square, then p divides a. Okay, here if p divides a square, p is a prime number. If p divides a square, we have to prove p divides a. Okay, and a is any positive integer. And we know that first theorem, that is fundamental theorem of arithmetic, we studied that any positive integer can be expressed as product of prime numbers, right? So here we can write, okay, here p is a prime number. Let p be a prime number. And okay, a be a positive integer. Therefore, a can be written as p1 into, that is product of prime factors. Okay, product of prime factors. So, a can be written as a is equal to p1 into p2 into p3 etc. pn. What are p1, p2, p3 etc. pn? Are prime numbers, prime factors. Okay, that is by the theorem of fundamental theorem of arithmetic, any positive integer can be expressed as product of prime factors. So here a can be written as p1 into p2 into p2, p3 into etc. into pn, where p1, p2, p3 etc. pn are prime factors. p1, p2 etc. pn are prime factors. Okay, then after that, see here it is given that p divides a square. If p divides a square, if p divides a square means, see what is a? p1, p2, p1 into p2 into p3 into etc. into pn. What is a square? p1 square into p2 square into p3 square etc. into pn square. Right? And it is given if p divides a square, if p divides a square. If p divides a square, what does it mean? That is, p is a factor of a square. If p divides a square, then p is a factor of a square. If here, and it is given that p is a prime number, that means p is a prime factor of a square. Right? P is a prime factor of a square. And here we have written a square is equal to the product of prime factors. That is p1 square, p2 square, p3 square, etc. pn square. Right? So here we can say p is, that implies p divides a square, means p is a prime factor of a square. Okay. Then this implies that p is one of these, p1, p2, etc. pn. Okay. Why? Because p is a prime factor of a square. Okay. Here p1, p2, p3, etc. pn are prime factors. Therefore, p is one of these, that is either p1 or p2, etc. or pn. Okay. So here that means p divides p1 into p2 into etc. into pn. Right? Either one of these means this p is one of these means p divides p1 into p2 into etc. into pn. Right? That implies p divides p1 into p2 into etc. pn. Right? What is p1 into p2 into etc. into pn? That is equal to a. Right? That implies p divides a. So here we have got, if p divides a square, then p divides a. That means p is a prime factor of a. Look at the next theorem, very important theorem. Square root of 2 is irrational. Square root of 2 is irrational. We know that square root of 2 is irrational. So here we have to prove square root of 2 is irrational. Okay. So for that, let's assume that square root of 2 is a rational number. Okay. Assume that. Let's assume that square root of 2 is rational. Okay, rational number. And we know that a rational number can be expressed in the form of p by q. P and q are integers, right? So here, this, if it is rational, then this can be written in the form of p by q, right? So here, square root of 2, then square root of 2 is equal to p by q. Okay, where p and q are integers. P and q are integers and q not equal to 0. Okay. After that, okay, let's take p and q are co-prime integers. Co-prime integers means a pair of integers having no common factors. Okay. So, let's take, let p and q have no common factors. No common factors. They are integers, but they don't have common factors. Okay. So here, after that, see, let's take this equation. Square root of 2 is equal to p by q. By squaring on both sides, 2 is equal to p square divided by q square. Okay. That is, square root of 2 is equal to p by q. That implies, on squaring both sides, 2 is equal to p square divided by q square. That implies 2q square is equal to p square. Okay. So here, see, we have got 2q square is equal to p square. That means 2 is a factor of p square. Right? See, for example, let's take some number. Okay, 2 into 5 is equal to 10. Right? See here, 2 into 5 is equal to 10. That means 2 is a factor of 10. Right? 2 is a factor of 10. That means 2 divides 10. Right? So here, similarly, 2 into q square is equal to p square. That implies 2 is a factor of q square, p square. Right? That implies 2 divides p square. Okay? This implies that 2 divides p square. Okay? 2 divides p square means 2 is a factor of p square. Okay. And by the first theorem, which theorem? if P divides A square, P is a prime number, okay, if P divides A square implies that P divides A, okay, if P divides A square then P divides A. See here 2 is a prime number, okay, so here 2 divides P square, that implies 2 divides A, sorry P, right, 2 divides P. If 2 divides P square then 2 divides P, okay. 2 divides P means 2 is a factor of P. That implies this P can be written as, see, 2 divides P square. Suppose it is P, okay. So now 2 is a factor of 10, right. So here this 10 can be written as 2 into any integer, right, because 2 is a factor of 10. 2 divides 10. Therefore, this 10 can be written as 2 into any integer. Here it is 5. Okay. So similarly, here 2 divides P. That means 2 is a factor of P. This implies P can be written as 2 into any integer m. Let's take this m. Okay. P is equal to 2 into m because 2 is a factor of P. Okay. Then after that, see, let's substitute this P is equal to 2m in this equation. Okay. So here we will get 2 into q square is equal to P is equal to 2m. So it will be P square means 4m square. Okay. That implies, see, 2 cancelled. So q square is equal to 2 cancelled, 2m square. Right. So here that implies, see, here q square is equal to 2m square. Here also 2 is a factor of q square, right. 2 is a factor of 10, right. 2 into 5 is equal to 10. See, 2 into m square is equal to q square. Therefore, 2 is a factor of q square. 2 is a factor of 10, right. So here similarly 2 is a factor of q square. That means 2 divides q square, right. 2 divides q square. That implies, by the theorem, 2 is a prime number. The theorem, if P divides A square, then P divides A, right. So if 2 divides, P is a prime number, here 2 is a prime number, right. So if 2 divides q square, then 2 divides q, right. If 2 divides q square, that implies 2 divides q. See here also we can write 2 divides q means 2 is a factor of q. 2 is a factor of q. That implies this q can be written as 2 into any integer. Let's take this integer be n. Okay. So this q can be written as q is equal to 2 into n. N is any integer. Okay, positive integer. So here we have got q is equal to 2n. And here p is equal to 2m. Okay, p is equal to 2m. See, here p and q both have, see, common factors, that is 2. Common factor 2. P and q have common factor 2. That implies P and Q have common factor 2. Right? See, it's wrong, right? Because it contradicts that P and Q have no common factors. Okay? This statement contradicts that P and Q have no common factors. Therefore, our assumption root 2 is rational is wrong. Thus, root 2 is irrational number. It contradicts that P and Q have no common factors. Thus, root 2 is irrational number. Now let's go through some important questions of irrational numbers. First question, prove that 3 root 2 is an irrational number. Okay, so here also we will apply the same method. That is, to prove the irrationality of the numbers, we use the method of contradiction. Okay, so here also let's assume that 3 root 2 be a rational number. Okay, 3 root 2 be a rational number. Therefore, this 3 root 2 can be written as in the form of p by q, right? That is 3 root 2 is equal to p by q. What are p and q? P and q are integers. Okay, are integers, and q not equal to 0. Okay, then here take this 3 here. So it is equal to p divided by 3q is equal to root 2. Okay, this can be written as p divided by 3q is equal to root 2. And here we know that p and q are integers, right? P and q are integers. Since q is an integer, 3q is also an integer, right? Since q is an integer, 3q is also an integer, right? Okay, therefore here p and 3q are integers. Now p divided by 3q. What is p divided? P and 3q are integers. Therefore p divided by 3q is a rational number, right? Since p and 3q are integers, p divided by 3q is a rational number. That implies, see, p divided by 3q is equal to square root of 2. That implies square root of 2 is a rational number, right? That implies square root of 2 is a rational number. Is it true? We have already proved that square root of 2 is an irrational number, right? Therefore, it contradicts the fact that square root of 2 is an irrational number. Okay, it contradicts the fact that square root of 2 is an irrational number, right? Thus, our assumption 3 root 2 is a rational number is wrong. Our assumption is wrong. Thus, 3 into root 2 is an irrational number. Thus, our assumption is wrong. Hence, 3 root 2 is an irrational number. What was our assumption? 3 into root 2 be a rational number, right? So here our assumption is wrong. Therefore, 3 into root 2 is an irrational number. So note it down. To prove the irrationality of numbers, we use the method of contradiction. Same method we have to apply. Next one, prove that root 3 is an irrational number. We know that root 2 is an irrational number. In the same method, we can prove root 3 is an irrational number. Okay, by the method of contradiction. So here also, first of all, let's assume that root 3 be a rational number. Therefore, root 3 can be written as p divided by q. P and q are integers integers and q not equal to 0, and let's take p and q are co-prime integers. Okay, that is p and q have no common factors. Let p and q have no common factors. Okay, then after that take this equation, root 3 is equal to p by q. That implies q into root 3 is equal to p. On squaring both sides, here we will get 3 q square is equal to p square. Okay, so here that implies 3 is a factor of p square. 3 is a factor of p square. That means 3 divides p square, right? 3 divides p square by the theorem, first theorem, if p divides a square, then p divides a. P is a prime integer, okay, prime factor, prime number. Here 3 is a prime number, right? So if 3 divides p square, that implies 3 divides p, right? If 3 divides p means 3 is a factor of p. Therefore this p can be written as 3 into any integer. Okay, that is m. Let this integer be m. Okay, so p is equal to 3m. M is any integer. Now let's substitute this p is equal to 3m in this equation. So here 3 into q square is equal to 9m square, right? P square is 3m whole square, right? That implies here 3 cancelled. So q square is equal to 3m square. See, again here 3 is a factor of q square. 3 is a factor of q square. What does it mean? 3 is a factor of q square means 3 divides q square. That implies 3 divides q square. By the theorem, we can say if 3 divides q square, 3 is a prime number. If 3 divides q square, 3 divides q, right? 3 divides q means 3 is a factor of q. That implies q can be written as 3 into any positive integer, that is let it be n. Okay, so q is equal to 3n. Now here we have got p is equal to 3m and q is equal to 3m. That means see, 3 is a factor of q and 3 is a factor of p and 3 is a factor of q. That is 3 is a common factor of p and q, right? Here we have got 3 is a common factor of p and q. But here we have taken p and q have no common factors. So it contradicts the fact that p and q have no common factor. Okay, it contradicts the fact that p and q have no common factors. So our assumption root 3 is a rational number is wrong. Okay, our assumption is wrong. Therefore, root 3 is an irrational number. Okay, therefore our assumption is wrong. Thus, root 3 is an irrational number. Next question, prove that 2 plus root 3 divided by 5 is an irrational number. An important question. So here also we have to prove given number is an irrational number. Here also we use the method of contradiction. So first of all, let's assume that 2 plus root 3 divided by 5 be a rational number. Therefore, since it is a rational number, this can be written in the form of p by q. 2 plus root 3 divided by 5 is equal to P divided by Q. What are P and Q? P and Q are integers Q and Q not equal to 0. Okay, so here let's simplify this equation. Take 5 right side. So it will be 5P divided by Q, okay, that is equal to 2 plus root 3. That implies take 2 left side. So it will be 5P divided by Q minus 2 is equal to root 3. That implies here it will be 5P, take LCM, 5P minus 2Q, 5P minus 2Q divided by Q is equal to root 3. Okay, and here we know that P and Q are integers. Since P is an integer, 5P is also an integer. Okay, since Q is an integer, 2Q is also an integer. And integer minus integer, again an integer, right? So here 5P and 2Q are integers. Okay, that implies 5P minus 2Q is also an integer. Okay, so here numerator 5P minus 2Q is an integer and Q is an integer. Okay, integer divided by integer. So here 5P minus 2Q divided by Q is a rational number. That implies 5P minus 2Q divided by Q, because 5P minus 2Q and Q are integers, right? Is therefore 5P minus 2Q divided by Q is a rational number. That implies if it is a rational number, then root 3 is a rational number. This implies root 3 is a rational number. But we have already proved that root 3 is an irrational number. Okay. So here we have got root 3 is a rational number. Okay. So it contradicts the fact that root 3 is an irrational number. Okay. It contradicts the fact that root 3 is an irrational number. Therefore, our assumption is wrong. What was our assumption? 2 plus root 3 divided by 5 is a rational number. Okay. Therefore, our assumption is wrong. Hence, 2 plus root 3 divided by 5 is an irrational number. Hence, 2 plus root 3 divided by 5 is an irrational number. Prove that 6 plus root 2 is an irrational number. CBSE 2010-2011 question. 6 plus root 2 is an irrational number. Okay. So here, first of all, let's assume that 6 plus root 2 be a rational number. Therefore, 6 plus root 2 can be written as P by Q form. That is, 6 plus root 2 is equal to P by Q. P and Q are integers and Q not equal to 0. And here, take this 6 right side, that is P divided by Q minus 6. Okay, taken 6 right side. So P by Q minus 6 is equal to square root of 2. Right? That implies, here just simplify taking LCM, P minus 6Q divided by q is equal to square root of 3. Okay. And we know that p and q are integers. Since q is an integer, 6q is an integer. Right? Therefore, p minus 6q. P is also an integer and 6q is also an integer. Therefore, integer minus integer again an integer. Right? So, here p and 6q are integers. That implies p minus 6q is also an integer. Right? So here p minus 6q is an integer and q is also an integer. Therefore p minus 6q divided by q is a rational number. Okay? That implies p minus 6q divided by q is a rational number. That implies it is equal to root 3, right? That implies root 3 is a rational number. Root 3 is a rational number. But it contradicts the fact that root 3 is an irrational number. We have already proved root 3 is an irrational number. So, this statement contradicts the fact that root 3 is an irrational number. It contradicts the fact that root 3 is an irrational number. Therefore, our assumption is wrong. Hence, 6 plus root 2 is an irrational number. Is a product of a rational number and an irrational number a rational number? Is product of two irrational numbers a rational number or an irrational number? Justify your answer. An important question. So here, first of all, first question is product of a rational number and an irrational number. See, take a rational number, okay, 2 and an irrational number 3. Okay, so product of 2 and root 3, square root of 3 is 2 root 3 is an irrational. Okay, so here we can say, see, if you take any rational number and multiply with an irrational number, you will get always an irrational number. Okay, so here we can say product of rational number, product of a rational number and an irrational number is always an irrational. Another example, 5 is a rational number and pi is an irrational, and product of 5 and pi is 5 pi is an irrational. Okay, therefore remember, product of rational number and irrational number is always an irrational number. Next one is not a rational number. Okay, so is product of two irrational numbers a rational number or an irrational number? See here, let's take an example. See, root 2 is an irrational number and root 3 is also an irrational number. So, product of root 2 and root 3 is root 2 into root 3, that is root 6 is an irrational, right? Irrational number. Then, another example, 2 plus root 5 is an irrational number and 2 minus root 5 is also an irrational number. but their product 2 plus root 5 into 2 minus root 5, it's in the form of a plus b into a minus b, right? That is a square minus b square. So here 4 minus 5, that is minus 1, is rational number, right? Minus 1 is a rational number. Therefore, here we have got product of two irrational numbers is either rational or irrational. Either rational or irrational. Okay? Prove that 2 root 3 plus root 5 is an irrational number. Also check whether 2 root 3 plus root 5 into 2 root 3 minus root 5 is rational or irrational. An important question. So first of all we have to prove 2 root 3 plus root 5 is an irrational number by the method of contradiction. So let's assume that 2 root 3 plus root 5 be irrational. Therefore, 2 root 3 plus root 5 can be written in the form of p by q. 2 root 3 plus root 5 is equal to p divided by q, where p and q are integers and q not equal to 0. Okay. Then after that, take this 2 root 3 right side. So it will be root 5 is equal to p divided by q minus 2 root 3. Okay. Then on squaring both sides, because here we have two irrational numbers, on both sides two irrational numbers, right? So here we have to square on both sides. On squaring both sides we will get root 5 square is 5 is equal to p square divided by, p by q minus 2 root 3 whole square. Okay. That implies here 5 is equal to a minus b whole square form. So a square, that is p square by q square minus 2ab. Okay. 2 into a into b. So 2 into 2 4. 4 root 3 into a by b. Sorry, not a, p by q. Minus plus, okay, p a square minus 2ab plus b square, right? So its square is 4 into 3, that is 12. Okay. After that, see here only one irrational number, root 3. So now we have to make this root 3 in one side. Okay. So for that, let's take 5 there. Okay. And take this minus 4 root 3 p by q left side. So 4 root 3 p by q is equal to, take 5 right side. So 12 minus 5, 7. So p square divided by q square minus 7. Okay. Sorry, plus 7, right? 12 minus 5 plus 7. Okay. After that, see here we need only root 3. Okay. So take this 4 p by q right side. This implies root 3 is equal to 4 p divided by q. So here it will be q divided by 4p into p square by q square plus 7. Okay. That implies root 3 is equal to, just to simplify this one. So here it will be p square q divided by 4 pq square plus 7q divided by 4p square. and take LCM. Here is q square. So here you will get q cube divided by here q square. Okay. Then it will be root 3 is equal to p square q plus 7q cube divided by 4pq square. Now here we know that p and q are integers. Okay. P and q are integers. Therefore, p square and q square, q cube all are integers. Okay. And p square q is also an integer. 7q cube is also an integer. 4pq square is also an integer. Here one q will be cancelled, right? Okay. So here p square plus 7q square divided by 4pq. Okay. So it's an integer, right? Numerator and denominator both are integers. Therefore, p square plus 7q square divided by 4pq is rational. Okay. P square plus 7q square is an integer and 4pq is also an integer. This implies it is a rational number. P square plus 7q square divided by 4pq is rational. Integer divided by integer, that is a rational number. Okay. Now, if it is rational, then root 3 is rational. Okay. This implies that root 3 is rational. But we know that root 3 is an irrational number. Okay. So it contradicts the fact that root 3 is an irrational. Okay. Therefore, our assumption is wrong. Hence, root 3 plus root 5 is an irrational number. Hence, root 3 plus root 5 is an irrational number. And next question is also check whether 2 root 3 plus root 5 into 2 root 3 minus root 5 is rational or irrational. See, now it's in the form a plus b into a minus b. We know that a plus b into a minus b is nothing but a square minus b square, right? So here 2 root 3 plus root 5 into 2 root 3 minus root 5. A plus b into a minus b, that is a square minus b square. A square, what is a here? 2 root 3. Its square is 2 square 4, root 3 into root 3, 3. 4 into 3, 12 minus b square. B is root 5, root 5 square is 5, that is 7. 7 is a rational number. Okay, 7 is rational. Therefore, its product, that is 2 root 3 plus root 5 into 2 root 3 minus root 5 is rational.